All right, hello everyone, and welcome to this Ethereum tutorial. In this quick video, we are going to look at how to mint an NFT. We're going to look at how to deploy it to an Ethereum test network, and then we're going to look at how NFTs use the IPFS, or Interplanetary File System, to store their assets. So let's get into it. I wanted to make this video because you hear all these talks online about, NFT sales and what is it, and they're actually really easy to mint and to put on a network. There's a couple of tutorials out there. There's one on the main Ethereum site, which is really good, but you have to sign up for all these things like Alchemy, and then you can interact with the blockchain through that. And I realized it's so much faster to just use an online IDE like Remix, so that's what we're going to do in this. So for starters, when we talk about NFTs, what they really are is they are an implementation of the ERC721 spec, which is a spec for non-fungible tokens. If you're familiar with ERC20, those are fungible tokens, meaning that every one is the same as every other one. If you're aware of altcoins, you look at things like Chainlink would be an example, or Matic. These are all ERC20 tokens, meaning in software terms, they implement the ERC20 interface. For a non-fungible token, we just need to implement this ERC721 interface. So to do that, let me grab a Remix window here, and I'll bring it over. Now, when you see how many lines of code this is, you're going to be kind of disappointed. Let's go over to contracts. I already kind of made one for NFTs, but let me make one called new NFT.sol. Okay, and what we're going to do, I'm just going to paste the code in here, and then we can kind of walk through it. It's very few lines of code. Most of it we're just taking from OpenZepplin here. If you want to read up on these in more detail, feel free to do so. But real quick, ERC721.sol is OpenZepplin's implementation of this interface. Counters is just a way of counting. It's aptly named, but basically we want to create an ID for each one of our NFTs. And to do that in this example, we're just going to have a counter that we increment. Ownable is an access modifier in Solidity, which just says, you can see it's being used here, public only owner on line 17. That just says that only the owner of this smart contract, only the person who deploys the contract that creates NFTs, has the ability to mint NFTs. Only owner here can call this function. And honestly, that's pretty much it here. We have an extension for URI storage, which we are going to use when we mint the NFT. That's how we're going to interact with IPFS. Don't worry if you don't know what IPFS is. But for starters, we have our smart contract here, okay? You can see it's compiling. That's awesome. So the first thing we need to do is we need to deploy this. We're going to deploy it to the Ropsten test network. I am going to use an injected Web3 provider here, which I recommend you do, assuming you've got MetaMask installed. And you can see I've already got an account on the test network. I've already got a bunch of Ropsten ETH. If you don't have MetaMask set up, please do so. And if you need a Ropsten faucet, I think one of these works. Pretty sure this one works. Yeah, you can just go here, go to MetaMask, copy your account, make sure you're on the test network, and then say, like, give me Ropsten F, and it's very generous. It's going to send 10 test ETH to my address, which is way more than you need. So, yeah, just make sure the correct contract is selected here. It's not my NFT, it's new NFT. Oh, but it's still called my NFT. Okay, sure, my NFT. And let's deploy it. Since we're deploying to the testnet using an injected Web3, we have to confirm that we want to spend some of our non-existent or our fake ether on this. Let's go ahead and view it on Etherscan just for fun. We can see it's pending. It's a contract creation because we're deploying the smart contract, and then the smart contract is what's going to allow us to keep track of the NFTs as we mint them. Cool. So it completed successfully. we can see that our smart contract now exists. Might have to go and refresh at this address here. And that's the same address that we have here under our deployed contracts. Great. So what this means is we could now call this mint NFT function, but when we call mint NFT, we have to specify a recipient, which is the address of the person who's going to own this NFT. In this case, we're just going to pass our own address because we're giving the NFT to ourselves. We also have to pass it a token URI. Now, token URI is interesting because when you see NFTs, whether they're used for like people's avatars on Twitter, or whether they're whatever it is, Bored Ape Yacht Club, or whether they're used for a more specific purpose, like for example, Decentraland, which uses NFTs to model virtual real estate, you have to have some assets with those NFTs in the form of like images or whatever it is that actually goes into creating the NFT. This smart contract represents the NFT's ownership on the blockchain, but the actual like creative assets, those you don't want to store those on the blockchain because storing stuff in permanent storage on the chain is very expensive in terms of gas. If you go into the Ethereum opcodes and you look at an S store for storing on storage, those are some of the most expensive operations in terms of gas. So we don't want to do that. Instead, we want to use a kind of an offline storage. And what we're going to use is IPFS. And one of the cool things about IPFS, real quick, is you can see down here they talk about blockchain developers. And they say IPFS content addressing enables you to store large files off-chain and put immutable permanent links and transactions, timestamping and securing content without having to put the data itself on-chain. The importance of this is when you store something on IPFS, basically it gets hashed. I believe it gets split into a bunch of smaller chunks and those get hashed. But the idea is because the data is hashed, and that's what we're going to use to reference the data stored in IPFS, much like blocks on the blockchain, because they're linked by hash, you'll know if any of the content has ever changed because that hash will change. And that's the way you can kind of ensure that your NFT is never tampered with, because if it were, the hash of the content of that NFT would change and you would know about it because, hey, the hash is different. So if you want to learn more about IPFS, there's certainly more information here. But what I'm going to use for now is this tool called Pinata, which makes it very easy to upload files and store them directly on IPFS. I do apologize. You will have to create an account with Pinata. I hate signing up for things. If you are not a fan of giving out your email address, you can use something like temp mail to sign up. I'm pretty sure that's totally okay to do, or don't do it. I don't know. I'm not advising you to do anything one way or another, but hey, I'm just saying, you know, that's a website that also exists. So in here, we're going to upload two things. We're going to upload an image for our NFT, and then we're going to upload a metadata file for our NFT. You can see I've actually already got some stuff in here. Well, you don't need to see how to upload. It's pretty obvious how you would upload it. So I have this asset here, which is an old record cover of a drunken penguin. You can see it has this IPFS URL here, and this is the hash that uniquely identifies this file, this image. And then I also have this metadata.json file, which is also stored in IPFS. This has some attributes here that I just copied over from a tutorial on Ethereum. So yeah, you don't really have to care about these attributes. What does matter, though, is this image field here in this JSON object. This IPFS URL, QMQP, whatever, is pointing to this image file here. So this JSON file is telling us that, hey, the image associated, lives at this URL. And the penguin's name is Donald, because I was listening to Steely Dan when I was doing this tutorial. And Donald Fagen isn't Steely Dan. So anyway, we've got our metadata JSON, so let us go ahead and open this in a new tab once more. I just need to copy this URL. Now, we're going to go back over to our Remix IDE, and we're going to do things. We're going to post this token URL here This is going to point to the JSON file. That's going to contain all the metadata for our NFT, and it's going to tell us how we can access images, and maybe you have videos, maybe you have all sorts of other stuff associated with your NFT. And then for the recipient's address, for now, I'm just going to go ahead and steal my own address here and use that. So again, we're on the test network. I'll just copy my account address, paste it here. I'm going to go ahead and hit transact. And again, I have to pay for the transaction. I'm going to go ahead and mint this. We can view it on Etherscan, but at this point, what's happening is if you delved into the ERC721 spec, you can't see it here because this is all within this OpenZepplin contract, but that is going to have a mapping internally of like addresses to token URIs saying, okay, this address owns this token URI, which is associated with this NFT. So all of that ownership, which address owns which NFT, is stored on the blockchain. If you're interested in learning more about that stuff in depth, please like post a comment or something, because otherwise I can't read your mind. But I'd be happy to like do a deep dive on it. Cool. So our thing succeeded and interacted with this contract here. So tokens were transferred. We did our little NFT thing, and yeah. So now that NFT is associated with this address, with my address. Unfortunately, the browser version of MetaMask does not give you a way to see like collectibles. You can see my RugMe token is coming along well. If anyone wants to see a tutorial on how to build a liquidity pool, let me know. But yeah, that's kind of the basics of how you would mint an NFT and how you would upload the files on IPFS. Apologies, I don't have a good way of actually showing you the output, but it is stored in the smart contract. So yeah, if you want to see this stuff in more detail, let me know, give me a post. And yeah, that is all for today. Thank you so much.